Ladies and gentlemen, we should already know about simplifying rational expressions, right? We always want to factor first to be able to get multiplication, to be able to cancel things out. And that comes from basic facts that we know. We know that x over x equals 1, it cancels out. We know that x to the third over x to the fifth, the 3x's on top cancel with the 3x's on the bottom. The answer is 1 over x squared. Why is that? Because there's pure multiplication. Even when we reduce a fraction like 4/10 reduces down to 2/5. But the question is, how does it reduce down to 2/5? Well, in a sense, you're factoring the 4, you're rewriting the 4 as a multiplication of 2 times 2, you're rewriting the 10 as a multiplication of 2 times 5, and of course, whenever you have a 2 over 2, that cancels out, and there's your answer, 2/5. Ta-da! Easy peasy. So we need to remember this, that you cannot cancel when there's addition or subtraction. That would be incorrect. But you could cancel when there's multiplication, all right? So on this particular expression, you cannot cancel the x's. Why not? Because there's a plus 3 on the x above. Now, if you had a times 3, then you'd be able to cancel. Even right here, you see that there's a 2x and a 2x. You cannot cancel the 2x's. Why not? Because there's a plus sign. You need pure multiplication, right? This says 2x plus 2. It'd be a different story if it said like 2x times a binomial or 2x times y or something else like that. You'd be able to cancel the 2x with the 2x if it were multiplication, but it's not, okay? So what should we do? This is what we do. We factor everything possible and then cancel. All right, so look at your numerator, look at your denominator, and factor. Factor anything possible, and then once you have the factored form, you have it with multiplication, then you'll be able to cancel. Okay, so if we take a look at this top one, 2x plus 2, we could pull out the GCF of 2. So when we pull out that 2, you could rewrite it to look like that. You'll have 2 parentheses x plus 1. And now you truly do have 2 times something over 2 times x. Now you really do have that multiplication of 2, and now you could really cancel that 2 with that 2, and this is your final answer. X plus 1 over x. X plus 1 over x. Okay, so this is on the notes. It's on the PDF copy that you already have attached on today's post. And we've done this before. It's pretty straightforward, pretty easy. All you do is factor everything possible and then cancel, right? That's what we're doing, okay? So is there anything to factor up on top? The answer is no. Is there something to factor on the bottom? Yeah, you could pull out the GCF of 3, and what would we have left over on the inside? Well, 3 times x would give us the above 3x. 3 times minus 3 would give us the above minus 9. So I have rewritten the 3x minus 9 as the factored form 3 parentheses x minus 3. So you could put a line right there through it. That way you don't get confused. And now you could look, what's on top? On top you have 3 times x. And on the bottom you also have 3 times, but a binomial, right? So you could now cancel the 3 with the 3 because of the multiplication. What's left over? There's an x up on top, and there's an x minus 3 on the bottom. And you cannot cancel that x with that x. Why not? Because there's a minus sign. You need pure multiplication. That is your answer. Okay, pretty simple. Let's take a look at this guy. Now there's many forms of factoring. Up on top you have a binomial x plus 4. There's nothing to factor there, so there's nothing to do. Let's just rewrite it. On the bottom, we do have a quadratic trinomial where the a value is 1. And on these types of problems, we could attempt to factor and rewrite it like this. And what numbers belong in here? The multiples of c that combine together to give us b. In case you forgot, what times what is negative 20, that if you combine together is negative 1, right? If you don't see it right off the bat, make a list. How could you get negative 20? Negative 1 times 20. Negative 2 times 10, negative 3 doesn't work, negative 4 times 5. Those are all the possible ways of multiplying numbers together to get negative 20 besides changing signs. So when you think about which pair of numbers combines together to give you b, When you combine -1 and 20, that'll give you 19. That b value's not 19, so that's not it. 10 minus 2 is 8. That b value's not 8, so that's not it. 5 minus 4 is 1. That b value is a -1, and we're getting a +1. That means we have the right number, the wrong sign, which means we have the right numbers right here, just the wrong signs. So please change this -4 to a positive, change that +5 to a negative, and you have that +4 and that -5 right there, and you have factored. Again, why did we factor? To be able to get multiplication between those parentheses, and now you could cancel whatever you could cancel now that you have multiplication. Now, again, let's get this straight. We are not canceling this x with that x and that 4 with that 4. We are not. We are canceling the entire binomial x plus 4 with the entire binomial x plus 4. That cancels out. What's left up on top? There's nothing left up on top, which we know we put a 1. And what's left on the bottom? An x minus 5. Voila, there's our final answer. We should all be comfortable with this already. Whoops. That looks interesting. We have not only, I mean, we're used to seeing this. Let me show you. Whoops, that didn't work. We are, what is going on? I need to, here we go. We are used to seeing a simple fraction and factoring and canceling, right? But right here we have a fraction times a fraction, and that's okay. What should we do? Factor everything possible and then cancel. Okay, so let's do this. Let's go through each numerator and each denominator because there's more than one fraction. Let's go to each numerator and each denominator and factor anything possible. So I'm going to go with the top left, the numerator on the left fraction, and I'm going to do it in red. What could I pull out of that binomial? I could pull out a x. That's my GCF. All right. So let me rewrite this first fraction right here. And up there, I will pull out the GCF of x. What would be left over on the inside? X plus 3. So I hope we all see that I rewrote this in factored form as this. Now let me go down to the bottom, the denominator of the first fraction, and that is a quadratic trinomial. So I should be able to rewrite it as this, thinking what times what is +2, that if I add together is -3. Well, if you're stuck, make a list, but there's only 1 times 2. That's the only way to get 2. And if you add those two together, that'll give us a +3, and we want it to be a -3. So we have the right numbers, just the wrong sign. So change both of those signs to a -1 times a -2. So a -1, -2. So we have factored the first fraction. As you can see, nothing cancels right there. Okay? So let's factor the second fraction. Up here on the numerator of the second fraction, we're going to rewrite that numerator in factored form. What times what is -2 that if I add together is -1? What times what is the c value of -2 that if I add together is a b value of -1? That will be a -2 times a +1. Okay? And finally, last but not least, let's factor x squared plus 4x plus 3. Again, you're thinking what times what is the c value of 3 that if you combine together is the b value of +4. So that would be a +3 times a +1. Now, I have finally factored everything, right? And that's what we do. We factor everything. You can't even see it. Oh, you factor everything possible and then cancel, right? We have factored everything possible. Now we truly have pure multiplication. Now let's cancel our little hearts out, right? X plus 3 up here will cancel with the x plus 3 down there. X plus 1 down here will cancel with the x plus 1 up there. Anything that is alike on top and bottom will cancel. The x minus 2 over here on top will cancel with the x minus 2 down here on the bottom. So keep in mind, guys, and let me emphasize this, it has to be canceling top and bottom. You can't have like an x plus 3 and an x plus 3 on the bottom and expect those to cancel. It has to be the exact same thing on the numerator and exact same thing with the denominator. It doesn't matter if it's on the other fraction. As long as one's on top and one's on the bottom, that's when they cancel. So what's our final answer here? Our final answer is this. X over x minus 1. Let me write that down. X over x minus 1. Do I need parentheses around this one? No, not really. But if I had anything else, left over in the bottom, like let's say there would have been a 5 left over on the bottom, then I would put it in parentheses and put the 5 on the outside, okay? But if it's the only thing left, like if it's just that binomial x minus 1 and there's nothing else, then you could just write it without the parentheses. So I hope we get it. There's one more type of question that we're going to be reviewing today. This guy right here. Actually, we're going to be reviewing more than one type of question, but this is the last new thing that we're covering, even though it's going to look like we're covering more, but it's all really this same type of problem. Okay, anyway, when we divide by a fraction, we really multiply by the reciprocal. Okay, so don't freak out. It looks crazy, but it's not. This division is going to become multiplication. Okay, so you got your first fraction, you got your second fraction. The division becomes multiplication only when you flip the second fraction, and only the second fraction. You have to flip it, okay? Let's go back to the basics. If I say 5 divided by the fraction 1/2, what I'm really saying is 5 times 2. 5 divided by 1/2 is really 5 times 2. Whenever you divide by a fraction, you really multiply by the reciprocal. So whenever you see division with the fraction, change the multiplication and flip the second fraction. Not the first. The first stays exactly the way it is. Okay? So I don't know. Let me do this. Since I have the ability to cut and paste, that's what I'm gonna do. Whoa, I messed that up, didn't I? Cutting and pasting. You guys are rewriting, I guess. Cutting. Whoops, I am messing this up again. Cutting and pasting. Cutting and pasting. Alrighty, so you guys on your paper should have, that didn't work. You guys on your paper should have rewritten it the way I did. Man, it would have been easier if I would have just rewritten it. Anyway, we flipped the division, we changed the division and multiplication and flipped the second fraction. Now what we need to do is factor everything possible. So let me not confuse you guys. Let me cover this. That didn't work, did it? Let me cover that. That's our new problem. Let's factor everything possible. Again, factor everything possible and then cancel. So this one's a little bit more complicated because we have an a value of 2. So I'm going to start with the other ones. I'm going to start with this guy down here. What times what is 9 that if I combine together is -6? Let me rewrite it in factored form. That would be a -3 times -3. That'll give us a +9. And if I add it together, it does give me a -6. What else? Over here we have the multiplication. And let me do this top one in blue. What times what is the c value of -12 that if I combine together is a b value of +1? Maybe I shouldn't have put the plus yet. What times what is -12 that if I add together is +1? That'll be a +4 times a -3. And of course, if you need help on that, make a list. And last but not least, let me go for this denominator in green. What times what is a c value of 16 that if I add together is a b value of 8? That is a +4 times a +4. That'll give us 16, and if I add it together, it's 8. Now, at this point, guys, at this point, I need to factor this guy, okay? Now, I will say this. There is opportunities to guess and check, all right? Now, what do I mean by that? Like, the only way, don't write this down, okay? Don't write this down. But the only way to end up with a 2x squared would be to have a 2x and an x, or an x and a 2x. So you could technically guess, like you could put a 2x right here and an x right there. And then you could look at your last numbers and think what times what is negative, or no. Look at your last number of -4, and how could you get -4? Well, it could be a -4 times 1 or a -1 times 4. And if you look at the denominators, it would be nice if this were a +4. That way it could cancel with the +4 down here. So this is a way of guessing and checking. But let's go back to the old school way, doing the multi-step process. When your a value is not 1, step 1 is to multiply a times c. That'll give you -8. Step 2 is to think of the multiples of -8, like -1 times 8 or -2 times 4. And that's all that you could possibly do besides changing signs. So which pair of numbers combines together to give us this b value of +7? That'll be a -1 plus 8. That'll give us a +7. You don't have to change any signs. So you have a -1 right there and a +8 right there. Okay, you know what? I shouldn't have left the 2x because that was me guessing and checking. Maybe I shouldn't even write that. Man, I am messing up. How about this? Yeah, let's ignore what I just did. Let's go back to this second step. We got the right pair of numbers. So let's move on to step 3. Step 3 is to either change the original quadratic trinomial into a polynomial, 4 terms, so you could use factoring by grouping, or you could use that magical shortcut. Here's a magical shortcut where you take this first term without the square and write it 2 times. So if this would have been a 3x squared, you would write 3x and 3x. If this would have been a 5y squared, you'd write a 5y and a 5y. If this would have been a 7p squared, you'd write a 7p and a 7p. And what do you do with the blank spots right here? You take this pair of numbers and plug them in. So you'll have a -1 and a +8. And the fourth, final magical step is to reduce whatever binomials you can. It's not like you're pulling out a GCF, well it is, but it's like that magical step of reducing or dividing by whatever you can. On the first fraction, you can't do anything. It's simply a 2x minus 1. You can't divide by anything. On the second fraction, you could reduce 2 and 8. You could divide both by 2, and that'll give you the new binomial x plus 4. And that was actually where we were going at when we originally guessed and checked, right? We were putting a 2x, we were putting an x, and we knew that it would have to be a +4 and a -1. That guessing would have worked, but it's important to know the multi-step process of factoring when your quadratic trinomial has an a value other than 1. In this case, the a value was 2. So now that everything is factored, then cancel, right? So what could we cancel? Let's take a look at x plus 4 down here will cancel with the x plus 4 up here. But then you have another x plus 4 up here that'll cancel with that other x plus 4 down there. Again, it has to be the top canceling with the bottom. The top canceling with the bottom. You cannot cancel both of these. They're both on the bottom. Okay, it has to be top with bottom or bottom with top. What else could we cancel? We could also cancel the x minus 3 down here with the x minus 3 up there. And ladies and gentlemen, that is our final answer. 2x minus 1 over x minus 3. That is our answer. I hope we understand it. Let's move on. Move on where? To the second part of the notes. Now, technically, guys, the second part is what I posted for tomorrow. It looks like this. But we're going to jump right into it. I know you're thinking, what? No. But you know what? We already know this. This section right here is called complex rational expressions. What's a rational expression? It's fractions. And this is definitely complicated. Why? Because you have fractions in the numerator and fractions in the denominator. You have a fraction divided by a fraction, which looks crazy, right? Check it out. The top fraction divided by that bottom fraction. That looks crazy. But you know what? It's not that crazy if we write it, if we understand what it says and we write it horizontally. Check it out. 3x divided by 5, that's the first fraction. That division bar, I'm going to write it as a division symbol. And then divided by what? Divided by the fraction 3/5. I would write this down if I were you guys, right? Top fraction divided by the bottom fraction. You're going to have this situation, but written horizontally instead of vertically. And now we could clearly see that the division changes to multiplication, but you got to flip that second fraction. So you have a 5/3 instead of a 3/5. The first fraction always stays the same. We just did this on the previous question. That's why I decided to jump right into this second part of the notes already, because it's really nothing new. You need to learn how to rewrite it. Instead of it being a fraction divided by a fraction like this, write it horizontally, fraction divided by that fraction. And then change it to multiplication, flip the second fraction, and you're good to go. Of course, try to factor anything possible. There's nothing to factor. So cancel anything possible because it is all pure multiplication. This 3 up here cancels with that 3 down there. This 5 down here cancels with that 5 up there. What's the only thing left? An x up on top. There's your answer, x. You see, it's easy. Now, if we take a look at this one, oh, that one looks complicated. It looks complicated, but it's not if you write it horizontally, right? So, I don't know, if you want, jot this down. And I like to get that big division bar and write it bigger, and I like to put it in red. That way, when I write it horizontally, you're going to see that division symbol in red. It'll make more sense to you. So the first fraction, I'm just going to rewrite it, x minus 4 over x. I do have that fraction divided by, in red, this second fraction, negative 4 plus x over x, right? I'm going to write this fraction, but you know what? This looks weird to me. I like seeing x first before numbers. So I might as well switch the order. This is a positive x, and this is a negative 4. So I'm going to write it that way. I'm going to write it as positive x with a negative 4. Okay? So all I did was I took the positive x and I wrote it first, took the negative 4 and wrote it second. Okay? Now it is over the x, so it is over the x, and that's all I've done. All I did was rewrite it from a vertical form to horizontal form, and now I could change this division to multiplication. Again, the first fraction does not flip. The division becomes multiplication, and the second fraction does flip. And now, try to factor anything possible, which you can't, but you could cancel things out. Check out the bottom x canceling with that top x. What else? We also have the entire binomial x minus 4 with the entire binomial x minus 4. Those cancel out as well, leaving your final answer. If everything cancels out, the answer is 1. 3 divided by 3 is 1. X divided by x is 1. Anything that completely cancels out is the answer 1. It's not that bad. Check out number 3. Once again, let's rewrite the top fraction, x squared minus 36 over 6x. Instead of this division bar, we're going to write it as a division symbol. And instead of 6 minus x, I might as well write it as a minus x plus 6. And of course, it is over 12. Okay, why did I switch the order of 6 and minus x? Because you want the x term first, you want your constant at the end. It's just the more appropriate way of writing it. So anyway, now we're going to change the division to multiplication. We're going to flip the second fraction, 12, with the negative x plus 6 on the bottom. The first fraction is going to stay the same, but you already know you're going to end up factoring, so we might as well, actually I don't want to confuse you, let me just bring it down. Now let's factor anything possible and then cancel. So on the top left, this is a difference of 2 squares, right? The square root of x squared is x, the square root of 36 is 6. So your factored form will be x plus 6, x minus 6. Or you could have thought, what times what is negative 36? That if I combine together is the middle value, which is nothing, well, yeah, that'd be a positive 6 and a negative 6. On the bottom, you can't factor it. That's simply 6x. You have a 12 up here. Now, over here, I could factor something out, especially if I want it to end up in a way that I could cancel it with something up here. So instead of a negative x, I would want a positive x. How could I do that? By factoring out a negative 1. So if I do pull out a negative 1, that negative x right there will actually be a positive x, and this plus 6 right here will actually be a negative 6. Does everybody understand how I pulled out that negative 1 right there? Okay, cool. And now that we have completely factored everything, now I could cancel whatever I could cancel. And what is it that I could cancel? I could cancel the x minus 6 up here with the x minus 6 down there. I could also cancel, technically, this 6 that's being multiplied with x. I could cancel the 6 with the above 12, right? 6 divided by 6 is 1. 12 divided by 6 is 2, right? It's like reducing. Or technically, you could think of it as 12 is really a 2 times 6, and the above 6 cancels with the below 6. You have a 2 left over. So what is our answer? Our answer is right here, x plus 6 with a 2 out in front. I just put the 2 out in front, right? And on the bottom, we have 1 times x times negative 1. So you could put negative x on the bottom. And ladies and gentlemen, that is 100% correct. This is your answer right here. Now, in math, there are many answers that are correct. What do I mean by this? A lot of math programs or some math teachers don't like seeing a negative in the denominator, so they could have also written it like this, 2 parentheses x plus 6 over x, and they simply take the negative sign and put it out in front of the fraction. This is also totally acceptable. Maybe if you're taking a multiple choice test and you don't see either of these answers, maybe they distributed the 2 back in. I wouldn't do this, but I'm just letting you know that it could be a correct answer as well, where they distribute 2 times x and 2 times 6 to give you 2x plus 12. So all 3 of these examples are 100% correct. I would go with this one right here, leaving it in factored form, or this one right here. Either of those are good. I don't see why you should distribute the 2 back in if you were trying to factor in the first place, right? So I wouldn't go with that blue one at the end. I would go with either one of the 2 at the beginning. So with that said, ladies and gentlemen, I'm going to leave this fun problem till tomorrow. But right now, you guys should be able to do this entire worksheet, right? Factor first and then cancel. Now, as you can see, the first questions, nothing is there to be factored. It's all pure multiplication. You just start canceling things out. 9 and 27 cancels out. 9 divided by 9 is 1. 27 divided by 9 is 3. A squared, there's 2 a's up on top. Canceling with 2 of the 4, you'll have 2 left over. There's 3 b's up on top that cancel with 3 of these 4. You'll have 1 left over. What's your final answer? Well, there's nothing left up on top, so you put a 1. On the bottom, you have 3a squared bc. There's your final answer for number 1. Straightforward, easy. Now, yeah, on the other questions, you will have to factor first and then cancel, right? And it gets fun. Like right here, we have difference of 2 squares, where you would have to rewrite it in factored form with that difference of 2 squares, where you take the square root of 25x squared, that's a 5x, where you take the square root of 1, and that's a 1. And of course, 1 has to be plus, 1 has to be minus. And you go through and factor everything possible, right? Like the bottom one, what times what is 25, that if you combine together is negative 10. That'll be a negative 5 and a negative 5. This other top one, you can't factor it, but this bottom one you could. You could pull out a 2, and you'll have a 5x minus 1. So we have factored everything possible. Now you could go back and cancel things out. Remember, you already rewrote this guy, you rewrote that guy, and you rewrote this guy. So what we're looking really is at the factored form, not at the original expressions anymore. So you could see that there's a binomial 5x minus 1 down here that'll cancel with the 5x minus 1 up there. You also see that this binomial, the entire numerator, x minus 5 up there, as a binomial cancels with the x minus 5 down here. And that's about it. So your final answer will be the 5x plus 1 that was left over up on top. And we do not need to put it in parentheses because there's nothing else left over up here. So you don't need parentheses around it. Now, this x minus 5 that's left over down there, you really do need that in parentheses. Why? Because there's something else left over. What is that something else? It's right here, the 2. So the 2 is going to go out there in the front. Ladies and gentlemen, there is your answer for number 12. Now, on the second page of this PDF homework is what we were just talking about, dividing by fractions. You have to change that division to multiplication. And that's where we also have these fractions that are written as division vertically which you should write horizontally. So you would write this top one divided by the bottom one, but horizontally, then change the division multiplication and flip the second fraction. Okay, guys, this is it. This is all we're doing for the rest of the week. Tomorrow, we're going to continue with this review. You guys are going to ask me questions. I want to help you guys, and we should be ready for the test on Friday. Okay, we're going to explain number 18. So number 18, you know you have division of a fraction, so you're going to change that division to multiplication, and you're going to flip the second fraction. So you're going to have a 5a plus 10 up on top and the 2a minus 6 on the bottom, okay? Now, the first fraction is not going to flip. The first fraction is going to stay the same. However, I might as well, since I have a 9 first and the a squared second, actually a negative a squared second, I might as well switch it. I'm going to write the negative a squared first and the positive 9 second, okay? Now, this one is an entertaining question. And the bottom one, the a squared plus 5a plus 6, that's a quadratic trinomial that we will be able to factor. Anyway, right now, we have flipped the second fraction. The division became multiplication. Now it's time to factor anything possible, okay? So what could I factor on this top one? Well, first of all, I like having the a value to be positive. So I will, on the top fraction, factor out a negative 1. You know what? Let me actually zoom in right here, and let me show you. I'm going to pull out a negative 1, and what I should have left is a positive a squared and a minus 9, okay? Now that should ring bells right there, because a squared minus 9, that's a difference of 2 squares. You could factor that. You could think what times what is negative 9, that if I add together is my middle value, which is nothing, okay? So let me rewrite my factored form of the upper left numerator. That's going to be a negative 1 times, but inside the parentheses, I really have parenthesis x plus 3, parenthesis x minus 3. Does that make sense?
Kind of.
Okay, so I could erase these parentheses up here, and I really have pure multiplication, negative 1 times x plus 3 times x minus 3, and all I've done is factored this top one. Let's now factor this one down here. Oh wait, I put x's instead of a's. I'm sorry, there's an a right there and an a right there, my bad. So this bottom one, what times what is 6, that if I combine together is a b value 5? That'll be a, that'll be a. What times what is 6, that if I combine together is 5? That'll be a positive 3 times a positive 2. That'll give you 6, and if you combine them together, it will be 5. And then over here, we could pull out, on the top one, we could pull out a 5 from both of these. So pull out a multiple of 5, and what do we have left? We will have an a plus 2 left over. And on the bottom one, down here, we could pull out a 2 from here and a 2 from there. So we're going to pull out a 2, and what's going to be left over? You will have an a minus 3 left over. So now we've completely factored everything. Now we're going to cancel out anything that's alike up on top and on bottom. The a plus 3 up here cancels with the a plus 3 down there. The a minus 3 up here cancels with the a minus 3 down there. The a plus 2 right here on the bottom cancels with the a plus 2 up there on top. So what's left over? You have a negative 1 times 5 over 2. So what is negative 1 times 5 over 2? Your final answer is negative 5 over 2.